Let's look at this question. John owns a salt distribution business and he needs to buy automated salt packing machines for his warehouse. The tables below now provide the data for the mass of 1,000, 1,000 boxes of salt, and is packed by two machines, X and Y. And so let's just color code that for ease of recognition. So X is here, and Y is here. So two different tables, right? This is for X, and this is for Y. Okay, for machine X, calculate the percentage of boxes that is less than 600 grams. And so we can see, okay, for machine X, we're looking at this table, mass M in grams. So it's a range, right? Greater or equal to 580, but strictly less than 590. 94 boxes fall into this category. And then you can see where it picks off, where it ends in below 590. Over here is from 590 onwards, greater or equal to 590, and strictly less than 600, and 542 boxes fall into this category, and so on and so forth. And so they say percentage of boxes less than 600, so it's less than 600. So these are the boxes that are all less than 600, right? From here onwards, it is greater or equal to 600. So we only care about these two numbers, less than 600. And so what we do, we just say percentage of boxes. So we say that, okay, the total number of boxes that are less than 600 divide by the total number of boxes overall. And of course, we find the percentage. You key all of that in, you should get 63.6%. Alright, and right now we're looking for the mean mass for X, machine X. And so we can see here, if you want to find the mean, which really is the average, right, you usually just add up all of the data and then you divide by number of data points. In this case, you want to add up like 94 boxes multiplied by the mass of the box. But you see, they give you a range. So you don't actually know what the exact mass is, you just know that it falls within that range. So when it comes to this kind of group data, we pick the middle point. So the middle point will be 585, right? And over here, the middle point is 595. This is the middle point, and this is the middle point. And so we want to multiply, when we want to multiply by the mass, we use the midpoint. So we're going to say it's going to be 94 times 585, right? So it's kind of like estimating. We're estimating that the 94 boxes, what mass do they have? We just pick the middle point, 585. And then we add to 542, multiplied by the number of boxes, which is, multiplied by the middle number for the mass, 595. And then we 238 multiplied by 605. And then 126 multiplied by 615. And if you key all of that in, it's kind of like finding the total mass, and then we divide by the number of boxes, which is 1,000. And so that will give us 598.96. And we can leave it as exact. And yep, I believe it's grams. Cool. And now we find the standard deviation. And so we know the standard deviation formula. It's given by square root. We sum up the frequency multiplied by each x squared value, divide by the total number, the sum of the frequencies. And this over here is really just the mean squared. Yeah. So this squared is really just the mean squared. So what we need to do now is we just need to calculate this part. So we sum up of the frequency multiplied by the x squared value. So we say the frequency is 94, for example, for the first one. And my x value is 585, but I square it. So it's going to be 94, right, multiplied by 585 squared. And then we just continue. Plus, 542 times 595 squared, and then 238,605 plus 126 and 615. Yep. And so that's the numerator, and we divide it by the total frequency, which is all of these added up together, all the frequencies, which will give us 1000. Yep. And so if I just fill this in, so actually this is, if I just say from the top here, how to get here, it's going to be the square root remains, and then the blue term is there, and then so now I have the mean square. So let's put it here. So it's going to be subtracting the mean. I found it here in the previous part. So it's 598.96 square. Square root covers the whole way. Yep. So basically, this square root is this square root, and then this term is this term, minus, and then this term is the mean squared. And you key all of that into a calculator, you should get 8.24. All right. Now John asks for your advice to decide which machine to buy. By comparing the performance of the two packing machines, which do you think is a better choice? Explain your answer. So we see over here, let's compare. For machine X, we got the mean mass, and we got the standard deviation. And then for machine Y, we have the mean here and the standard deviation, and we're trying to compare both. And so we can first see that the standard deviations are honestly quite similar, because it's grams, and if the box that you're packing is like 600 over grams, then this difference is like 8.24 minus 7.9. It's really not much. Standard deviation, we can take it as they're similar. But I look at the mean, which one is closer to 600? I think it's clear that machine X is closer to 600. And you can see that, we're trying to automate the salt packing, right? And so you want all of them to be packed like the same amount of salt in each box. And we see that, okay, over here, a lot of them are very close to 590 to all the way 610. And we see that the mean is like 603, and the mean here is 598. So it seems that we are trying to pack boxes of 600 grams. And so we can see that machine X is closer, it's a lot closer actually to packing 600 grams. And so thus we can say that machine X is a better choice. The standard deviation is similar. But X packs closer to 600. Grams mass. Because as a someone selling salt, you don't want like one box to have 1,000 grams, the other box has 10 grams, right? You want the machine to do well, and what well means is that it packs consistently the same amount of mass. And if you want it to be 600, then you want the mass to be close to 600. You want the mean to be close to 600. Yeah, and there you go.